Hello and welcome to our lesson on intersections, unions, and compound inequalities. This is going to be from section 1.5 in our text, and we are going to jump straight into the examples. Number 3, here we have the set containing the letters A, B, C, D. The symbol here in the middle is the intersection symbol. So it says the first set intersected with the set containing the letters B, F, G. I guess one of the things that would be nice to know is that intersection corresponds with the word and later in the compound inequalities. And here what we're looking for, since it says intersection, we're looking for elements that the sets have in common. So the answer for this intersection would be, well, B. B is the only element that these sets have in common. And so the intersection of these two sets would be the set containing the letter B. And that's done. All right, next problem, number 7. Here we have the exact same sets, but this time we have the union symbol. And again, it might be nice to know that later this is going to correspond with the word or in our compound inequalities. But here, since we're looking for the union of the two sets, you need to know that union means to combine the elements of both sets. So any element that exists in either set will be in the union. So this will be the set containing the letters A, B, C, D. Notice I already accounted for B in the second set, so then we need to add F and G. And that's going to be it for problem number 7. For our next example, number 19, here we have what's called a compound inequality. And the reason this is called a compound inequality is we have two inequality symbols connected this time with the word and. So the goal here is to solve each inequality separately, and then we will combine them according to the term that's used here in the middle, which is and. All right, so to get started, first inequality, we're going to move the 7 over. That's going to give us 3x greater than or equal to negative 3. Remember, the 7 comes over and makes minus 7. 4 minus 7 is negative 3. And then we're going to divide both sides by 3 to get the x by itself. And that'll give us x is greater than or equal to negative 1. So that is the first part of the inequality done. And we're going to bring the and down. And we're going to solve the other inequality. 2x greater than or equal to negative 5 becomes plus 5. 5 minus 1 is 4. And then we're going to divide both sides by 2. And that's going to give us x is greater than or equal to 2. And now that is solved for. If we go back and read the instructions, it says solve and graph on the number line. So now we're going to look at graphing this on the number line. Here we have two critical points, negative 1 and 2. Those are our two critical points. Those are both going to have solid dots because we have the equal to on the inequalities. And then we're going to shade each inequality. So for x is greater than or equal to negative 1, greater than or equal to means shade to the right. And do you see that it shades forever to the right? The other inequality, x is greater than or equal to 2, since it's greater than, it's also going to shade to the right forever. And now we can consider what word was used in the middle. Well, this is an and remember that corresponds with intersection. And if you think about what intersection means, intersect means where two things come together. So we're looking for where the shadings overlap. And that's going to be everything from 2 to infinity. So on the number line, if we were to graph just the solution for the compound inequality, we would go to 2, and you can either use a bracket or a solid dot, either way, and shade to the right. That is the answer graphically that represents the compound inequality. And then just for fun, we are going to express that in interval notation. So in interval notation, that would say everything from 2 to infinity. Okay, so there's going to be 3 pieces for the answers for the remaining examples. You're going to have the solution, the graph, and the interval notation for the rest of the examples we do. Okay, for our next example, number 33, here this is also a compound inequality. Again, because we have 2 inequality symbols in the same statement. So, to solve this particular compound inequality, if I'm going to get the x by itself, the first thing I have to get rid of is the minus 7. So doing the opposite operation, I'm going to add 7. But if I add 7 to the middle piece, I have to add 7 to every piece. Every section gets a plus 7. And then we're going to combine like terms. Negative 18 plus 7, that's negative 11. Less than or equal to negative 2x less than 7. And then the next step, to get the x by itself, I'm going to have to divide everybody by negative 2. Dividing every piece by negative 2. Warning, danger, Will Robinson. Remember, when you divide by a negative, the inequalities have to flip. So that is true of any inequality problem. If you divide by a negative, the inequalities have to flip. And so for the first section here, negative over a negative makes a plus. That's going to be a plus 11 halves. The x is now isolated. 7 divided by negative 2 is negative 7 halves. Now, to the number line. I've got 2 critical points. Negative 7 halves and 11 halves. You do need to put those in the right order. So negative numbers to the left, positive numbers to the right. And then we're going to break this down into pieces. So I'm going to try to color code this for you. This first statement says, if I read it backwards, it says x is less than or equal to 11 has. And since it has the equal to part, I'm going to have a solid dot. Again, reading this, or if you want to read it forwards, 11 halves is greater than or equal to x. So that means that 11 halves will be the biggest number in that statement, and we're going to shade to the left because any other value is going to have to be less than or equal to 11 halves. I hope that's clear. Now, for the other piece of this statement, here we have x is greater than negative 7 halves. And since this does not have the equal to piece, that's going to correspond to an open circle. And if it's greater than, it's going to shade to the right. So if I combine these together into one shading, we're going to have an open circle shaded all the way up to 11 halves with a solid dot. So that is the answer graphically for this compound inequality. We are going to express that in interval notation. So we're going to have a parenthesis, which corresponds to the open circle. And then the shading starts at -7/2 and stops at 11/2, and the solid dot corresponds to a bracket. And there is the interval notation that represents that shaded region on the graph. Our next example, number 21, here we have another compound inequality, this time with an AND statement. And so we're going to have to solve each inequality separately. First of all, bringing the 4 over, that's going to make that -4. And that'll give me -3x greater than or equal to 6. Next step, divide both sides by -3. Next step, divide both sides by -3. -3's will cancel. And don't forget that if you divide by a negative, the inequality has to flip. 6 divided by -3 is -2, and we're done with the first one. And the next inequality, we're going to bring the -2 over. Makes that a +2. And that'll give me 5x greater than 15. Next step, divide both sides by 5. X is greater than 3. And that is the solution so far. Now to the number line. I've got two critical points, -2 and 3. Please make sure you put those in the right order. -2 is going to have a solid dot because of the equal to part. 3, since it doesn't have the equal to part, will be an open circle. And if I haven't said this before, I'm going to say it now. If the letter is on the left, you shade the way the arrow points, or the way the inequality points. So here, since the x is on the left-hand side of this statement, from -2, we're going to shade the way the inequality points. And that always works as long as the letter is on the left. Okay, let's do it again. If the letter's on the left, shade the way the arrow points. So from 3, we're going to shade to the right. Now that we have the shading done, we can consider the word that's in the middle, which is an and, which means intersection. So that means the solution will be where these two shadings overlap. However, they don't overlap. So in this case, since we have an and statement and the shadings don't overlap, the answer is no solution. There's no solution to this. Now, there's two ways that you can express no solution. You can use this symbol here. That means no solution. Or you can have an empty set of braces. Remember, braces mean the set of, but if there's nothing in there, it means there's no answer. It's the set of nothing. This is another way that you can say no solution. Either one of these should be acceptable. But if you're doing MyLab math, I'm going to guess it's probably going to be this symbol here. And that's it for that problem. And before I move on to the next one, let me give you one other little piece of information. The only way that a compound inequality can be no solution is if it's an and inequality. An or would always have a solution. Or can never be no solution. But here, like in this example, and can sometimes be no solution. In our next example, number 49, we have another compound inequality. And this time we have the word or in between. And so we're going to get to see this time how or is different than and when you're doing a compound inequality. First things first, though, we need to solve the first inequality. Bringing the 5 over is going to make that a -5. 7 minus 5 is 2. greater than negative 4x. And then if I divide both sides by negative 4, remember dividing by a negative makes the inequality flip. And 2 over 4, that's going to be negative half. So we're going to end up with a fraction this time, but that's okay. Fractions are not that big of a deal. And there's our statement. And I got to tell you, I don't feel really good about the x being on the right-hand side. So what I'm going to do is I'm going to go ahead and flip this inequality so that the x is on the left. And the reason I like it like that is because when the x is on the left, you shade the way the inequality points. That's just a nice trick to know. Anytime the letter's on the left, you shade the way the arrow points, okay? Or, now for the other inequality, we're going to move the plus 5 over, which will make it a minus 5. 10 minus 5 is 5. Less than or equal to negative 4x. And then if I divide by negative 4, again, I'm dividing by a negative, so the inequality flips. And 5/4 will not reduce. And that is an improper fraction. And that's the way I like it. I like it improper. But I don't like the letter on the right. So again, I'm going to flip this around. And do you see when I flip it, the inequality still has to point to the x. So x is less than or equal to negative 5/4. And now that we have both inequalities solved for, we can go to the number line. I've got 2 critical points. You do need to put those in the right order. So if you're not sure which one of those is the smallest, you can convert to a decimal and compare. But I happen to know that an improper fraction is going to be bigger than a proper fraction. And the bigger a negative is, the smaller it is. So the negative 5/4 is going to be the smaller value. And then the negative 1/2. The negative 1/2 is going to have an open circle. You see, because he doesn't have the equal to part. And the 5/4, or the negative 5/4, will have a solid dot, because he does have the equal to part. And now we're going to have to figure out the shading. So if x is greater than negative half, greater than means shade to the right of negative half. X is less than negative 5/4. Less than means to the left of negative 5/4. And now we can talk about what word did we have? Well, we had or, which corresponds to a union. A union means taking the stuff that each have and putting it all together. So since this is a union, then this graph is the solution. This is the graphical solution for this compound inequality. And now let's talk about how this would look in interval notation. So remember, interval notation describes what is shaded from left to right. So this shading is going to start at negative infinity, and it will shade all the way up to 5/4 with a bracket because it's a solid dot. And then you notice you've got a gap where there's no shading. So we're going to put the union symbol. Just remember, the U is the glue that sticks the 2 pieces together. So then we're going to pick up at negative half, and the shading will continue to infinity. And please don't forget that infinities always get parentheses. Infinities get parentheses. And that is it for that problem. Okay, next example, we have number 51, another compound inequality where we have the or statement. And we're going to solve each inequality separately. So if I bring the negative 7 over, that'll make it a plus 7. Negative 10 plus 7 is negative 3. And then if I divide both sides by 3, that's going to give me x is greater than negative 1. First part done. Or, then we're going to bring the 2 over, which makes minus 2. And that's going to give me 5x is less than or equal to 20. And then if I divide both sides by 5, that'll give me x is less than or equal to 4. So, not much trouble there getting the x's by itself. Now, to the number line. I've got two critical points, negative 1 and 4. Remember, you have to put those in the right order. Negative 1 is an open circle. 4 is a solid dot. And from negative 1, notice it says x is greater than negative 1. So we're going to shade to the right all the way to infinity. X is less than or equal to 4, less than or equal to, we're going to shade to the left all the way to infinity. Now, since we have an or, remember an or is the same as a union, which means that you take the two shadings and you combine them. Okay? The two shadings united is the solution set. So if I sandwich these together, the graphical representation of the solution set would be this. Just like that. Everything would be shaded. Do you see? It's shades to minus infinity. And then the shading never stops. And then it keeps going to infinity. So this would mean that the solution set is all real numbers. Now, how do we express all real numbers in interval notation? Well, where does the shading start? On the left, it starts at negative infinity, and it never stops. It just keeps going to infinity. And so this is how you would express all real numbers in interval notation. And that is it for problem number 51. And here we have our last example for this lesson, number 53. We have another compound inequality, another OR statement. Let's get started. Bringing the negative 2 over makes it a plus 2. Negative 6 plus 2 is negative 4. And then if I divide both sides by negative 2, remember dividing by a negative makes the inequality flip. And a negative over a negative makes a positive 2. So there's the first part done. Or, and now we're going to do it again. Negative 2 makes a plus 2. That's going to give me negative 2x greater than 8. And then if I divide both sides by negative 2 again, remember that dividing by a negative makes the inequality flip. 8 over negative 2, negative and a positive make a negative 4. Now there's the solution done. Now to the number line. I've got two critical points. Negative 4 and 2. They're both open this time. X is greater than 2, shades to the right. X is less than negative 4, shades to the left. And we have the word or, which means union. And so since there is a gap in the middle, then this is the graphical representation of the union. That is the answer for the graph. Now we need to write the interval notation. So again, the shading goes to negative infinity, all the way up to negative 4, with a parenthesis that corresponds with the open circle. And then remember, if you're doing an OR and there's a gap in the middle, the U is the glue that sticks the two pieces together. And the shading picks up at 2 and goes to infinity. And that is our interval notation for that compound inequality. And that's going to do it for this lesson. So, if you have any questions or comments over anything I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.